All right. So good afternoon again. What we are going to discuss today is not essentially the theoretical class that we have been discussing, but uh, as you know that we have already talked about folds, and it is essential that we, uh, as a part of our lab class, structural lab class, we get exposed ourselves to the structural maps that involves folding. Now, Institute's guideline, of course, is that the lab class will take place after you are back. But as you are seeing that the number of lockdowns are keep on increasing, and when the institute will open is anybody's guess. Hope it opens soon, and we could practice some more maps while you are back, or do some more exercises on structural lab. But uh, if that doesn't happen, I don't want you to be completely devoid of any practice on any structural maps. And it also makes sense, as we have discussed, folds, while your memory is kind of fresh, you get on with these maps as well. So what I will do today essentially is to introduce two structural maps which contains problems related to folds, and then I will send you these two maps also to practice by email. Uh, you can solve them at home after taking printouts, or you can solve them after you are back here. Depends on you. But when you are back here, I want you to submit these two maps in your lab journals once you are back. Okay. So what we are going to do, we are going to discuss two maps, and we will follow the same guidelines that we have been following in our lab class to solve these maps. Okay. So and I want it to be a little bit interactive, like our normal lab classes. So I will recommend that if I ask you a question, if you want to answer, please unmute and talk about it. Okay, so that we have more or less an interactive session. Of course, it is not ideal to carry out a lab session in a video call or in a video class, but still we will give it our best, and at least you will not be devoid of any experience of working with maps that involves folds. All right, so let us look at the first map. Okay, so you can see here it's it's the similar type of map that you have been looking into, and it has two sets of lines. The bold lines, of course, denotes your bed boundaries. They denote bed boundaries, and the scale is given here. 1 inch is equals to 1,000 feet. It has its legends as well. So it has four types of lithologies: grit, sandstone, mudstone, and shell. Okay. So if I just ask you where would the north be, because the north is not given here, it will be towards this side, right? Because that's the no, that's the top side of the map, right? So we can actually rotate this map back and do that exercise. But for a specific reason, I have kept this map in this orientation. But that should not be a problem. You know, your north is this side, right? Because this is the bottom of the map. So this is my north. Now, I said that this map involves folding. And how do I know that it involves folding? You can see the first clue that should come to your mind when you look at a map, that whether it has a fold into it or not, that you try for looking into repetition of strata. Okay. So you can see here what I am observing, that I have shell in the middle, and on the either side of shell I have uh, mudstone, and then sandstone, and then of course grit. Okay. And now here if you look, here I have grit, and then on the either side of the grit I have sandstone, as well as then mudstone, and then shell. Shell again comes back here. So I have a repetition of beds on the horizontal section. The same bed gets repeated, right? So that is the first clue that will that should be with you to say that this is perhaps you are looking at a folded structure, right? Now, so the first step that we have to do essentially is to draw strike lines. Okay? So I have drawn strike lines for you, and you can, when I send you the map, you can draw these strike lines by yourself, and you can see that here merely drawing one set of strike lines or two sets of strike lines were not enough, because uh, as I said, the reason you try to draw your strike lines is to check your dips, dip direction as well, right? So here you can see I have drawn 700 feet 700 feet contour between mudstone and shell. Then this is 600 feet contour between mudstone and shell, and this is 500 feet contour between mudstone and shell. So from here you can very well calculate. So these are my strike lines, and for these set of beds, you can very well calculate the amount of dip just by the formula that we have talked about, that you measure the horizontal distance and then you use it. So you typically uh, take a triangle, you measure the horizontal distance. This is the horizontal distance, of course, between two strike lines, right? The horizontal distance between two strike lines, and then you try to find the contour interval, right? So this distance you measure in the scale of the map, and then the vertical distance as given by the contour values. So if you are doing it between 600 and 700, so this will be around 100 feet divided by and then the base will be the distance between contoured lines, respective contours, and that is measured in the scale of the map, right? And you can calculate the dip, right? Like you have done before in the lab class. So there will be a dip. I am not calculating it for you. You can calculate it by yourself. But you can see here, this is 700, this is 600, this is 500 for the same bed boundary. So that means that the dip direction is towards. So if this is north, is north. So then this is around northwest. Sorry, around southwest, right? Now, if you come back to the other side, here I have drawn 700 shell mudstone. So I'm going from A to B. So here, that's why this was mudstone shell. So I'm now, if I come from shell to mudstone, I see from this side, this is 700 shell mudstone, this is 600 shell mudstone, and this is 500 shell mudstone. And so I can see that the deep direction here is exactly opposite to the dip direction here, right? So this is towards northeast, and this was towards southwest. So I have dip directions which are like this. So they are away from each other. So what type of structure are we looking at here? If the dip directions are away from each other in a fold, and why do I say this is fold? Simply because I have repetition of strata, and I explained that in the theory class. We do see in the outcrop pattern the repetition of strata, right? That is the typical signature of a fold. And then I am seeing that the beds are dipping away from each other, right? So what type of structure are we looking at? Can anyone unmute and tell me what type of structure are we looking at here? Or you can type. Come on. Prashasti, tell me what type of structure are we looking at here? Rohan, tell me what type of structure are we looking at here? Rohan Diwar, Mr. Rohan Diwar, tell me what type of structure are we looking at here? Come on, guys. Prashasti, it's an anticline. Yeah, more. We exactly don't know. I mean, we can say it's an antiform, right? So this is an antiform because they are closing upward, of course, right? Now, if we come back to this part of the map, what we are observing, again, I have drawn strike lines, and then so this is 700 sandstone grit. This is 600 sandstone grit. So then the dip direction is towards northeast, and here 600 grit sandstone, and this is 700 grit sandstone. So the dip direction is again towards southwest. Now here I am seeing that the dip directions are towards each other. Okay, so the dip directions are towards each other. So looking at a structure with repetition of beds where the dip directions are towards each other, right? So if I have dip direction towards each other, then I am perhaps looking at a thin form, right? So I have one antiform and then a corresponding syn form in this map. Are you convinced? Any question that you have? So I can see here actually four dip directions, one here, another here, another here, another here, right? So a consecutive antiform and syn form, that is what we are observing. Now, I am asking you to actually draw a cross section from A to B, okay? And this line, this traverse from A to B is actually perpendicular to the strike line, right? They are perpendicular to the strike line. So if it is perpendicular to the strike line, what does that mean? Do we need to calculate apparent dip or not? Do we need to calculate apparent dip? Sahil, tell me, do we need to calculate apparent dip here? Sahil Prakash, yes or no? Can anyone tell me whether we need to calculate apparent dip here or not? The traverse is perpendicular to the strike lines. No, Ratichi says we don't need to calculate the apparent dip. Okay, so we simply can work with the true dip that we have calculated here. But of course, we need to exaggerate the dip. Yeah, we already have told you that simply because, say here 1,000 feet is equals to 1 inch, so your map will be extremely clumsy. So exaggerate your you have to exaggerate your uh, you have to exaggerate your x-axis, right? You have to exaggerate your x-axis, sorry, y-axis. So if you exaggerate your y-axis and keep the horizontal axis fixed, then as I can see that the dip will be exaggerated in the cross section. So we need to calculate this dip, okay, which is, and the process of calculating the dip we have also talked about in the lab class. So say for example you calculate the dip here is around 5 degrees, and then after exaggeration, exaggerated dip, depending on your vertical scale, you calculate say around 30 degrees. So that is what you will use, right? So you can see that more or less the spacing between the strike lines are more or less similar. So the amount of dip is more or less the same for all the beds, but the dip direction changes. So the dip direction starts from southwest, then becomes northeast, then again becomes southwest, and then again becomes, sorry, then it becomes again northeast. It remains at northeast, and then it goes on southwest again, right? So I see consecutive antic forms and syn forms here, right? So now I have to draw a cross section along A and B with the information that we have collected from this map, right? So now if I see from A to B, what we have to do, we have to first look at the contour values, okay? So what I'm seeing with respect to the contour values, this is 1,000 feet, then 900 feet, and 800 feet, 1,000 it is not there. So 900 feet, 800 feet, 700 feet, 600 feet. So it decreases, it goes all the way up to 400 feet around, okay? And then it starts to increase again, 500, 600, 700, 800, okay? And then perhaps this will decrease again, this becomes 700, okay? So it keeps on increasing, so it becomes a hill. Sorry, it keeps on decreasing, so it becomes a valley, and from the valley it becomes another hill, and again the height of the hill starts to decrease as we move towards hill. Are you convinced that it becomes a valley here, and then it again becomes a hill here, and then the height of the hill slowly decreases? So that's how my topography will look like, right? So I have tried to draw the topography very simply. Say, for example, this line, different color. So this green line is my topography, right? So it starts. So it's a rough topography that I have drawn just by looking at the map. You will do a better job when you actually create that topography. So you can see that it starts with a higher value. So here you can see it starts with a higher value, which is around 900 feet, and then it goes somewhere around 400 feet. Yeah. Then it again attains slowly increasing, attains 800 feet. So it goes all the way up to here, and then the value of the hill actually decreases, right? And then it goes away. So just by looking at the topography, what you can observe that I have a valley and a hill. So a valley and then a mountain, and then again another valley, a valley, a hill, and then another valley. Now then I will plot my respective bed boundaries. So this is the bed boundary between uh, grit and sandstone. Okay, and so and as you can see, dip this should dip towards A. So grit to sandstone dips towards A, sandstone to mudstone dip towards A, mudstone to shell dip towards A. Then shell to mudstone dips towards B, uh, mudstone to sandstone dips towards B, sandstone to grit dip towards B, then grit to sandstone again dips towards A. Then sandstone to mudstone dips towards A, and then mudstone to shell again dips towards A. So I have towards A dip direction, and then I have towards B dip direction, then again I have towards A dip direction, right? So that's what we are observing in the map, right? As you can see here, dip direction towards A, dip direction towards B all the way up to here, and then again dip direction towards A, right? And then I will plot my beds, and this is how the beds will look like this, these bed boundaries. Okay. Now you can see here that I have to do a little bit of uh, uh, manipulation on this drawing. So as you can see here, that this part has been eroded away, but as we can see that there is the repetition of the bed. What I can do, I can simply construct the hypothetical hinge zone of this anticline. Okay, but as I have put a dotted line over it, that means this part is eroded. And ideally, you will, when you draw by yourself, you will draw straight lines like this, right? These bed boundaries will be straight lines. So one bed boundary will be like this, and then the other bed boundary will be very sharp, terminating against it, right? Very sharp, terminating against it, like this. But what you are supposed to do, of course, is to essentially draw, keep the straight line up to this, and then remove that part and kind of draw a beautiful carved syncline here, because that's how it should be. Here as well, I have given the example, maybe a mudstone sandstone bed boundary here, and the sandstone mudstone bed boundaries here. They are sharp, but then I will perhaps remove this part and then draw a beautiful curvature here, and similarly here. So that will essentially construct my cross section, right? So I can see the development of a beautiful antiform, and then the development of a synform, right? Now, if I look at this cross section, of course, if I ask you to draw the stratigraphy, how the stratigraphy will be. So the first thing that comes is, of course, shell, and above shell I have of you. So the first is shell, the oldest one is shell, and then the next one is mudstone, then comes sandstone, and the youngest one is grit, of course. Okay. So this is my Yongin direction. The oldest rock is shell, then it is sandstone, then it is grit. Okay. So of course, so this is an antiform, but then the oldest rock is at its core. So this is also an anticline. Yeah. This is a synform, and the youngest rock is at its core. So this is also a syncline. So I have, like Prasasti said at the first, so this is also an anticline and a syncline. Okay. So this is antiform as well as anticline. This is synform as well as syncline. Okay. Now, if I look at the so what happened? We had the deposition of shell, the deposition of mudstone, deposition of sandstone, and the deposition of grit, and then everything got folded, right? Everything there was a, say, perhaps there was a compression. So where from the compression essentially came? So if I ask you to draw here the fold axis orientation will be like this, right? You can imagine. Fold axis will be like this. So this is one fold axis. This is the fold axis of the anticline. This is the fold axis of the anticline, and this is the fold axis of the syncline. Now, so if I have the folded strata in the fold axis is like this, so I can imagine that the compression that came to form these folds were kind of perpendicular to this fold axis, right? That is where the compression came from. Okay, so this particular structure did develop because of a northwest southeast compression. Sorry, so my north is here. Yeah, so northeast southwest compression, right? Because this is north is here, that's fine. So northeast southwest compression, right? That has essentially developed my structure. Now, with respect to depositional environment, if you think that it is shell, so shell is extremely fine grained. Mudstone means the fine, it is, less fine grained, it becomes coarser. Sandstone is even coarser, and grit is extremely coarse grained sandstone, right? So the grain size essentially increases as it becomes younger. So we are perhaps going from a distal to a proximal source, right? We are perhaps going from a, and I hope you know what distal means and what proximal means. From a distal to a proximal source, right? Or you can think, say, for example, we are perhaps going from a floodplain deposit. If it is alluvium, we are perhaps going from a floodplain deposit to something which is channel, right? Channel. So uh, in terms of depositional environment, this is what we are looking at. Suppose I have a river. Okay? I have a river, and then where would shell develop? This is where shell will develop because this is floodplain, right? Mudstone will be developed somewhere here, as you are going very much towards the bank, and then sandstone and grit will be developed here. So what do I mean by that? So what has happened? That the river has essentially migrated from this side to that side with time. Okay? Because I see the development of shell first, and then mudstone has got over it, and then sandstone and grit had come even over it. So that means that the canal has migrated from this side to the overbank deposit. Hence, I am observing a stratigraphy which starts from shell and ends up in grit, right? And then after the deposition, what has happened? There was a compression that came from northeast southwest, and that folded the strata, and the folded and the fold essentially developed a pair of anticline and syncline. Is this clear, everyone? If not, just say if it is clear. It's important that I know that this is clear. Everything that I have talked about this particular fold. Is it clear? Let me ask Akash, is it clear? Anything you have not understood? Yeah? I could not hear you. You can type, please. Excellent. So whatever we are talking here also in the about the maps, they are included in your syllabus, right? So they are, we can ask, I will ask questions on folds in your lab exam as well. So I will, if you have a question, if you have a doubt, you can ask now, but they are pretty much included in your syllabus, okay? All right, so I hope you have understood this particular map. And now let us get into a little more difficult map with a fold. Okay? So I will give you a moment to look at this map first, and then I will explain. Just familiarize your eyes with with this map, okay? Just for a moment. Okay, so let me just take you through this particular map. So you can see here the north is very well shown, right? The north is marked. The scale is 1 centimeter is equals to 100 meter. And I can see many different things in this map. Okay. So the first thing that comes to my mind, the most conspicuous part of the map, is that I can see these lines which are cutting across the bed boundaries as well as the contour lines. Okay. So what are these lines? These straight lines? They are, can someone write down, please? What is this, Aniket? What are these two lines? Write down. Aniket, are you sleeping?
So false.
Faults. Very good. They are faults. So what else do you observe here? Let me ask Ashwin. Tell me, what else do you observe here?
Uh,
Other than fault, do you observe any other discontinuity?
uh, uh, yes, sir. There is a discontinuity.
So what that discontinuity is?
Uh,
and where it is.
Okay.
What is
Uh,
happening here? You can see where my cursor is.
yes, sir. Yes, sir. I can see. I can see it.
So what is this? Can you tell me?
Uh,
We have done this exercise before.
yes, sir. Like I.
It's an unconformity, right?
Yes, sir. Yes, sir. That's the
That's an
term that slipped my head. I'm really sorry.
yeah, no
Like
worries. So
you
this
know.
is an unconformity. You recognize. Everyone
Yes, yeah,
recognizes.
now I recall it. Yes,
Yeah. So this is an unconformity. Very
yes,
good. Now, what type of unconformity? This is. I'll give you the answer. This is an angular unconformity simply because I can see, of course, the latitude of the beds below and above are different, right? So this is an angular unconformity. Okay. Now, Arthi, tell me whether the fault had come earlier or the unconformity is the younger. Which one is younger? Faults or unconformity? Arthi, tell me. Which one is older? Which one is younger? Seems Arthi is sleeping again. Okay, Manish, tell me which one came earlier, fault or the unconformity? Manish Mehra. He is sleeping as well or too shy.
Sir,
Pankaj,
everyone is typing.
sorry, typing
Everyone is replying like in text.
in text. Okay. Faults. Unconformity is younger. Okay, I'm sorry. Thank you, Akarsh. We have not talked about faults yet. So tell me about faults and unconformity. Which one came younger? Which one is younger? So I can see one, and unconformity is younger. Okay, that is excellent. True. Simply because what you can see here that uh, this fault has not cut across this unconformity. So first the fault came, then there was no faulting, and then the unconformity essentially came, right? We have not talked about faults yet, just faults and unconformities. Okay. Now, if I talk about faults, what I see here, so I have how many beds do we have? We have C, D, E, F, so 4, and then we have R, S, T, Q, 4, 4, 8. So we have 8 beds in this particular map, right? 8 beds. Now, I don't see any repetition of strata between in R, S, T, Q. Okay, there is no repetition of data, and by now, by looking at the contour pattern, you can say that they are monoclines. Okay, they are dipping in a single direction. Now, but if I see now between C, D, E, and F within this set of data, below the unconformity, of course, you can see that there is a repetition of beds. So there is C, and then there is on the either side of C, I have D and E and F. Okay. And then also across the fault, I can also see that C, either side of it, D, E, and F. Okay. And here as well. So now I ask you, which one came earlier, whether the fault came earlier or the fault came earlier? What happened first, folding or faulting? Write down the answer, please. Anyone? Which happened earlier, folding or faulting? Folding. Excellent. So the folding happened, and then the whole strata got faulted. Okay, that's very good. Now, what else we do observe here? That these faults, if I ask you to calculate the dip of these faults, okay, that will be impossible to calculate from here, simply because I can see that these contour lines are cross-cutting these faults only at one point. Okay, as you can see here, in both these faults, these contour lines are cross-cutting them. It's a single contour line cross-cutting them only at a single point. So what does that mean? What type of faults are they? They are perhaps vertical faults. Okay. They are vertical faults. Otherwise, if they would have not been a vertical fault, if they would have been a fault with some dip, okay, then what you would have seen that these contour lines would have cut them at more than one places, depending on their dip. Okay. And we have seen, we have already we have shown you in the previous classes how to calculate the dip of a fault. So these are vertical faults. Then when the faults are vertical, can you tell me what type of faults do we see with dips being vertical? Just write down. What type of faults do have dips 90 degree? What faults? What category? Strike slip fault. Excellent, Pratibha. So these are all strike slip faults. Okay. So if I have a strike slip fault, can I observe, if it is 100% strike slip fault, can I observe any displacement on a cross section? Yes or no? Just answer me in yes or no. If it is 100% strike slip fault, is it possible to observe any displacement in a cross section? Yes or no? No. Excellent. We will not be able to see any displacement in the cross section. So where would we expect to see the displacement? The displacement will only be seen in the map view, right? Like it is being shown here. Okay. So we can calculate or measure the displacement only in the map view. Okay. So far, so good. Clear? Now, with this background, let us try to proceed with this map. Okay. So I have very nicely marked with this dotted red line the presence of that unconformity. Okay. And then I have tried to draw the strike lines. Okay. So this is 500 CD strike line. This is 400 CD strike line. So the dip direction is towards this side, right? Towards N, right? Towards N. And then this is 600 DC strike line, and this is 700 DC strike line. Okay, so the dip direction is towards M. So what type of structure is there in between? In the middle, we talked about it. So this is an synform, right? Because the dips are towards each other. So this is a synform. Okay. Now if you do, and I want you to find out what sort of, so now with F, I can also see that E is on the either side. So what sort of faulting is there, you will find out by yourself. So I see a synform, and perhaps I will see another antiform here. I can give you that. Okay. So there will be an antiform, perhaps there will be a synform. Okay. So series of antiforms and synforms. Okay. And then there were these two faults, okay, which actually displaced everything in this strike slip direction. Okay. And I can calculate the displacement at any single point by drawing the strike lines. So now, say for example, here, this is 600 D by C strike line, right? And that terminates at the fault at this point, right? This point. So this is the point of intersection of 600 DC strike line. Okay. Now, so you can also see that this particular strike line on the other side of the fault is also, this is 600. Just let me check. This is 600. This is also 600 DC, right? This is 600 DC, but on the other side of the fault. So that means this strike line has been displaced from here to here, right? So I can simply measure this distance, whatever the distance is, in centimeter, and then convert that into meter with the map scale and say that the displacement of, say this is 1 centimeter. I don't know. Maybe you can measure properly. Say this is 1 centimeter. So the displacement is around 100 meter. Is it clear? Just tell me if this is clear or not. So we don't need to, like, previously when we worked with a normal fault or worked with a thrust, what we have done, we had to actually draw a cross section, right? When we could calculate the displacement. You remember that from our earlier exercise, right? But here we don't need to do that because I will not be able to see the displacement for a strike slip fault in the first place on a cross section. So we have to draw it. We have to calculate it in the map itself. Okay. And how we are doing it? So I have drawn the 600 DC strike line, and then also on the other side, I have drawn the 600 DC strike line, and then I can see the distance between these two points, right? And then this distance will be the displacement. Is it clear? Tell me if it is clear. Yes or no? Just write yes or no. Okay, very good. So that's how I have calculated my strike line. So by that, I can then say that the first set of event, what happened, that these beds C, D, E, F, that got deposited. Now, when you draw the cross section, you will be able to understand which one came earlier and which one came later. Okay, by looking at the structure. Okay, so then you can draw the stratigraphy C, D, E, F, and then there was folding. The next episode was folding. And of course, if the folding is like this, if it is like this, then the fold axis will be this, right? This is the general latitude of the fold axis. This is my fold axis. If this is the fold axis, of course, the compression came perpendicular to the fold axis. So due to the fold, due to the compression from this side, this is northwest southeast, the compression from northwest southeast, these beds got folded. After folding, what happened? The next thing is this strike slip faulting. There was then strike slip faulting. And then I had erosion, of course, and that erosion is marked by this unconformity. And then there was the development of, QRST beds. Okay, clear? Now, within these beds, which one came earlier, which one came later, you can simply figure them out after drawing your cross section. Now, if I try to draw the cross section, what I am observing that just by looking at the contour values, this is starting from 400, 500, 600, 700, 800, 900, 1000. So simply there is a increase in topography from M to N. The topography essentially increases from M to N. Are you convinced? And then from here to here, perhaps you will see the development of anticline, this, and then syncline. And as I said, I will not be able to see the faults. First of all, from M and N, it doesn't cross-cut the fault. So I will not be anyway be able to see them. But even if I would have taken a cross-section which is, like this, I would have taken a cross-section from here to here, then also I would have not been able to see them simply because that's a strike-slip fault. Okay. And then there will be an unconformity. Now the unconformity, for the unconformity, you have to calculate the dip. Okay. Because you can see here that the unconformity crosses. So this is my 800 meter strike line. This is my 800-meter contour. So I can draw the unconformity, the strike line on the unconformity on 800 meter, and then I can draw the strike line on the unconformity at 700 meter as well. Okay, so I can calculate the dip on the unconformity, say, and the dip direction. So whatever, I can draw my unconformity here. So this is my unconformity. And on the top of the unconformity, then there will be another set of beds. Will be my which will be my. So these are my CDEF set of beds. These are my CDEF set of beds. These are my CDEF set of beds. And these are my QRST set of beds. And then I can simply, so now if I want to draw the stratigraphy, so first these CDEF set of beds came, and that you have to figure out which one came early, which one came later. And then the second phase is, of course, the folding because of the compression that came along MN. Okay. And then, of course, the development of faulting. The next stage is faulting. F1, F2, and both are strike-slip faults. And then, of course, the development of unconformity. And then on the top of it, I had the other set of beds, which are QRST. Okay? Is it clear? Please write down yes or no. Anyone? Harsh, is it clear? Harsh Pushkar, is it clear?
Yes, sir.
Yeah? Okay, good. So what I will do, I will send you these two maps. you try to solve them at home. I mean, you try to work them out with proper description and everything, all the written, all like you have done your map exercises, and submit them once you are back. Okay. So even if we don't have any lab classes uh, anymore, if when you are back, you are covered with all the maps that you are supposed to be exposed to. If we get the chance to have more lab classes, we will of course practice and uh, you know uh, see more complicated maps where we have all these discontinuities and faults and everything. But if not, you at least have got the gist of the different elements that a structural map can have. Okay. All right, then I will stop the lecture here. I will send the maps to you, and I expect to see the completed maps in your lab journals when you are back. And I'll see you on Monday again. Oh, sorry, Friday again. Thank you.